Chapter 5 Sample Problem 14. The cantilever beam is subjected to the load intensity force per unit length, which varies as the function say here omega 0 sinus pi.x on L. Determine the shear force V and bending moment M as a function of x on L. At first, we should calculate the external forces at the support here. So, consider this picture for calculating the external forces as reaction force. The reaction force B0 and M0 sigma F y equals to 0, the y direction V0 equals to R, and R equals to the integration of omega dx. R equals to omega is omega 0 sinus px on L dx from 0 to L, which is equals to minus omega L on P cosinus px 0 to L omega L on pi cosinus, with the substitution to this relation, cosinus pi minus 1 and minus cosinus 0, which is 1. R equals to 2 omega 0 L on pi, which is V0. The reaction of the force at the support. Sigma M V equals to 0, M 0 equals to the integration of x multiplied to omega dx. Omega 0 x sinus px on L dx from 0 to L. Can write in here. With pi method, U sinus px L du equals to pl cosinus px on L, and dv equals to x actually we can choose u equals to du omega 0 dx, dv equals to sinus px dx our integration becomes uv minus v du uv omega 0 L on px cosinus px L minus v du. M0 have this relation. Plus L square P square omega 0 sinus px on L from 0 to L. So MB can be calculated. With L we have the first part L minus 1 plus omega 0 L2 on pi. The second part for L sinus pi equals to 0. For 0 we have this part is 0 and this part is also M can be rewrite as this relation. A omega 0 L2 on pi. And because we choose the positive this direction, cantilever was plus, so our M appears with the minus sign with this direction. M0 on pi. So we have this reaction on the beam. Consider these beams. M0 V0 and a force distributed here. To obtain the shear force and bending moment, we choose an section here with this shape. Consider this picture. We know that for a distributed force and the section chosen here, we have this relation d v on dx equals to minus omega dx. duration of dv from 0 to L, 0 to L, v minus v0, omega 0 sinus pi x on L dx. So v equal to v0 plus v0 calculated before, 2 omega 0 on pi plus again L on p pi cosinus this is x. To x this distance. Plus omega 0 L on pi cosinus pi x on L. For 0 we have 1 minus 1. So we can write the relation as plus 1. pi.x on w omega 0 L 1 on pi cosinus pi x plus 1. We obtain a relation for v on plus 1 so at x0 1 plus 2 on pi and at x equals to L, zero. If we sketch the shear force function, we can obtain the diagram as this picture. To obtain the relation for moment dm v dx, dm equals to, we obtained it before as this relation, omega cosinus pi x plus 1 dx from 0 to x dm equals 0 to x v dx. We can obtain this relation. M omega plus x from 0 to x. Sinus pi x plus x, and in the zero condition we have two parts 0. M can be calculated. M0 can obtain it before, plus final answer. If we sketch the moment diagram, we can obtain this picture.